Hello everyone, welcome to GIS Man. I'm Miles Lee. In my last video, we have already talked about one of the very useful FME design patterns called List Convergence with Python programming. And in this video, we will continue to talk about this topic, but a little bit deeper. In the last video, we converged the features with spatial relationships into one-dimensional list. But in this video, we will converge the features with various spatial relationships into two-dimensional lists. Some people may say, why do we need to use two-dimensional lists? As one-dimensional list is already enough for many cases. Yes, that's right. But in some scenarios, we still need to use the higher dimensional list to facilitate our process and make our process to be less redundant and more efficient. So let's take a look at these cases. So in this scenario, we have a network like this, and in the middle, we can see we have a main row which has several segments, and at the end of this main row, for both sides, we have the intersection which connects to different fork rows. Okay, so the requirement here is that firstly, we will need to average the value for both sides. And then based on these averaging values, we will need to deduct the value for each segment for our main row based on the formula like this. Okay, so in these cases, if we use two-dimensional lists, the work will become easier and the algorithm will be much clearer. Okay, so let's take a look in our ArcMap to see the real situation. So this is the network sampling area that I extract from my real project. So in this row network, what we can see is that there is a bridge right here. This is our main row, and then at the end of this bridge, we have some fork row. Okay, so for the fork row, what we can see is that it has the efficient value, the correct value, and it has the same link number and a row number. It's also for this side. But for our main row, what we can see is that our value is empty. So what we need to do is to derive the value from both sides and then assign the value to each segment of our main row based on these algorithms. So in these cases, when we use two-dimensional lists, we can see lots of advantages. So now let's do that. So here we go. Firstly, we will need to read in our row network. Our row network name is called sample network-2. And then after that, we will need to separate our supplier from our requester, because after that, we will have some spatial relationship. Okay, so we will need to use our text filter to do that. And then for the supplier and the requester, we will need to use the to be process to separate them. For our main row, which we will need to derive the value from its adjacent supplier, it has the to be process C. And then for the supplier, it will have the to be process value F. So we will do that. Okay, so these two streams will be going into our spatial relator. So our main row is a requester and adjacent fork row, okay, is our supplier. for our first dimensional list. So here, this is our first dimensional list. We will need to use the touch requester touch supplier to build up the spatial relationship and then converge the features into our first dimensional list. So let's give it a name. We can say the first dimensional list will be attached rows, okay? And by here, we have already established our first list to be converged, okay? And then after that, we will need to use our geometry extractor. This is a standard ETOR design pattern. We will need to extract our geometry and then recover it at the end of our process. If you don't know what is the ETOR design pattern, please watch my previous video, which is very useful for you to understand what we are doing right here. Okay, so after that, what we need to do is use the line combiner to establish our second dimensional list. This step, what we are going to do is to combine all the segments for our main row to construct one very long road, you know. So in this case, we need to generate a list, select all attributes, and then the list name, what we can say is, let me think about it, it's called CR roads. Okay, the second list, CR roads. And for this case, we push all our individual segments for our main row into the list. This is a second dimensional list. Okay, so after this, we will need to sort our list a little bit. List sorter. The reason is that because when the features we put into the list is unordered, so we will need to sort it and make it to be ordered. So in that case, it will follow the directions. So we will need to sort the list. What we are going to do is to sort the list by the attributes CR link number. Yes, right here. Okay. We need to use the numeric as well. So after that, our key row is coming, the PythonCaller. Okay, so I have already prepared two formula. One is the averaging and the other one is the interpolation. These two formula is to implement the averaging for the both sides for row as well as the interpolation for each segment's value for our main row. Okay, so to save time, I have already implemented these two functions. And what we need to do is to apply these functions to our two-dimensional list. So let's take a look how to do that. Firstly, of course, we will need to intake our list. Firstly, we will need to intake our CR rows list. Let's take a look where it is. CR rows list is right here. Yep. Which is our first dimensional list. It stores all features for our main row. Okay, so with this one, what we are going to do is to calculate how many segments are there in the main rows. Okay, because this is the list actually is the array. So we can use the len function to calculate how many segments, how many elements are there in the list. So right here, I can calculate how many segments of the row in the main row, okay? And then we need to have two index. One is the index 1 and the other one is the index 2. The index 1 means the starting point of our main row. For example, is from this side. And then the index 2, we will use the number of our links minus 1, which means the end point of our main row, which is this one. Okay, so now what we are going to do is to calculating the averaging for both sides for rows. We can use the formula, we can use the averaging functions right here. So let's do that. Here we will need to intake two-dimensional list at the same time. So firstly, we need to intake our first dimensional list. We need to use a placeholder right here to indicate that now we have already used the first dimensional list, and then within it we take our second dimensional list. If you imagine in the normal programming language, two-dimensional list in FME is equal to two-dimensional array. So we need to use a placeholder here to indicate that, okay, we have already logged our first dimensional array, and then within the first dimensional array, we find out our second dimensional array and find out the elements inside this second dimensional array, okay? So that's what we are doing right here. Sorry. And then similarly, this can help us to get second dimensional list for the starting point of our row network, which is this one. So similarly, we can take the ending point 1. Similarly, we will have the placeholder to anchor our first dimensional list, and then within it we find our second dimensional list value. Okay, so the index will be this one, which indicates the end of our row network. Okay, start and end. And after that, we can use our functions here to calculate the average for both ends. The A1, A2, A3, A4, and C1, C2, C3's average values. So we give to variable new average equals to our averaging functions. This is our first one, and it will returns the value, the final value for averaging of A1, A2, A3, A4. And then similarly, we calculate C1, C2, C3's averaging value. Okay, so what's next is to use our formula right here to interpolate the values into each segment of our main row, B1, B2, and B3. Okay, so what we are going to do right here is to look through in our first dimensional list. Because the first dimensional list, again, is store each segments of our main row. So we use our formula defined at the top of our Python. And then we will need to pass several parameters. It has the starting point. Starting point's derived value, which is our averaging value for A1, A2, A3, A4. And then also we have the ending point's averaging value for our C1, C2, and C3. Okay, so this one will be put here. And then again, we need to have our index. I forgot to input the index for it. The index will be changed for each step of our looping. So for each step of our looping, it will return different values. That's how we interpolate different values into our segments of the main rows. Okay, and then we will need to have a number of links which indicates how many segments are there. The reason why we do this is that if you look at this formula, the I, which is the index, CPy and APy is the averaging value for both sides, and then N is how many segments are there in our main rows. Currently we have 3 segments, okay? So that's why we do that. And then we will need to write our result value back to each segment of our main rows. Okay, so don't forget, for each iteration, we will need to self-increment our index. Okay, so everything looks good. Finally, don't forget to recover our geometry replacer. This is the standard process of our ETOR design pattern. Again, I strongly recommend you to look back my previous video. Sorry for that, I forgot to explode the list exploder, because now everything is hidden in our first dimensional and the second dimensional list. So in order to use the information, we will need to explode it. So we will need to explode it right here and only use our list attributes. Why we need to just explode our first dimensions? Because that's the main row. That's the main row. That's what we want to derive the value from our adjacent fork rows. And this main row segments is converged in our first dimensional list. So we just need to explode the first dimensional list. We don't need to worry about the second dimensional list right here, because it was just used to calculate, to help calculate the value. Okay, so we just explode that, and then now we will need to explode, replace our geometry. Okay, so now everything looks good, and we will need to write it into our result. So I'll give you a name, result, okay, And because right here we just explore our first dimensional list, which store each segments of our main row. This is what we like to have to fill in the AADT derive, which is now empty. But however, we also need to retain other row networks. Okay, so we can take it from the beginning to get, or like a sec. This one should be to supply. Yeah. So now when we do that, our network will be complete. Let's take a run. Just wait for a while. Looks good, it's fast. So let's refresh our GDB. Now we have the result right here. And let's take a look. Let's enable our original network. Okay, so right here, let's take a check our main row first. There are 3 segments. Now what we can see is that the value has already been calculated based on the formulas right here. Okay, so we can also check our adjacent supplier. So let's take a look. So for these two, it will be averaging, and then for these two, it will be averaging, and then the main row in between, the value will be calculated, will be interpolated based on the formulas right here. That's why you can say there are some float values, because when we use the interpolation, the value might be not the integer. Okay, but anyway, I mean, the result shows that our 2-dimensional calculation is successful. So that's the video for today. And again, I would like to say that, I mean, maybe using the 2-dimensional list is a little bit complex in FME. The writing style is quite different from the normal programming language, but you can imagine it's just equals to the 2-dimensional array. If you know how to use a 2-dimensional array in Python, you can understand how to do it in FME as well. And it empowers the methods, and it makes our process quite easy. You see, if we don't use the 2-dimensional list right here, I mean, we will need to write a lot more things to implement the same functions and implement the same algorithms for the complex row network. So hopefully this can help you a bit in your daily work. And if you have any questions, please don't hesitate to discuss with me together. So thanks for your watching, and see you next time. Bye.